right, last before the coffee break, we have Lori Schultz from NASA telling us what they've been doing and the questions.
Good morning, everybody. I'm giving this presentation on behalf of the SERVIR program, who I've gotten to enjoy working with here in the last few years. To Jim's point, one of Jim's other hats that he wears in the SERVIR program is he works with the SERVIR program to build capacity across the different nodes. 5 seconds about SERVIR, joint initiative, NASA, USAID. It's been around for about 17, 18 years. And the idea is to share the science that we have with places, build capacity in places, but not in a way that's like, here, we're smarter than you, here, have it. It's to serve, it's to teach, and it's to expand the knowledge. And so they started in the Central American region and spread out all sorts of cool places, Hindu Kush being one of them. We've heard some of the other areas from Jim. But in the 17, 18 years that they've been around, funding different applied science projects. I think they just awarded their 4th set of 3-year projects. Some themes have popped up, as one would expect. Problems are the same in lots of different places. And so over the years, they've had some opportunities to bring together not just the science leads that were provided from NASA, but more importantly, the science leads from the different hubs, to bring them together under these thematic areas to share their experiences, to share their knowledge. And so we'll talk a little bit about that today, and some of the work that we get to do in the Hindu Kush region and how it kind of explores further outward into the sharing across the networks and the hubs. And so quick, I'm not going to get into the details of this slide, and quite honestly, it's probably a little hard to read in that green. Just a highlight of some of the projects, and if you can see the little numbers in the sides, which projects spanned which 3 years, where they moved to, and then some of the connections that were made. So the project I worked on was led by Franz Meyer out of the University of Alaska Fairbanks, and to bring the use of SAR data to the Hindu Kush Himalayan region, which, unbeknownst to me, I don't think they see sun for 6 months out of the year. They have amazing flooding in monsoon seasons. Again, something I'd never seen or experienced. And so for me, an awesome experience to learn about the area and to see how they deal with things. SAR data, obviously, for all the obvious reasons, being able to see through the clouds, being able to map water in a way that they hadn't been able to do before. They have some in situ observations in certain areas, previous ASTs, with forecasting geoglows, bringing the information to the area, but again, tying it to observations of when it was happening. And so the co-development of this service with the brilliant people in the ECMI region to bring the RTC products that are freely available from the Sentinel satellites and ESA, and then develop products with them that work for what their needs are. The RTCs that were developed at the ASF, to be able to pick out water quickly, to pick out vegetation quickly. The water extents for obvious reasons. Where's the water? Any water at this particular point. And then because of interest in the region, trying to crack the nut on observational flood depths in areas, and then exploring whether or not different tools like change detection and agriculture in the area, could be valuable. But again, part of the co-development process was, trying to figure out what, once they understood what the tools were, letting them figure out what it is that they needed, where it was going to work, where it was going to fit. Interesting, lesson learned, we'll talk about a little bit more later, is how we were going to deliver the data, but we did choose to deliver it as a web resource. And as NASA's pushing into this space, we do everything in the cloud. It's particularly useful with the SAR data and the huge data transfer rates. When I started working with Franz, downloading this data would, be an hour of my day before I could do anything useful with it. And that was on a decent, internet connection. And so, again, doing all of this in the cloud and delivering the data in a way that doesn't, overwhelm systems was a pretty important part. And so, okay, there's the algorithm, we do stuff. It's actually similarly based to the one of the algorithms being used in the ESA flood product that we heard about yesterday. And again, the development with them, on how to use this information, where it would be valuable, and the things that they had to teach us about the region, which you'll see here shortly, because we can talk about the science any other day. This here was, as we delivered the data to them, it was important to them to choose how they wanted to share the information. And so this web viewer was built by the folks in ECMod based on the feedback that we had received in multiple training sessions, all done remotely, sadly, due to the COVID crisis, but with the pieces and parts that they asked for the pieces and parts they knew they users wanted, this was the web app that they developed. And then, although not shown here, easily linked to a download system where all the geotiffs are available for download for users to do additional analysis with. And we had the opportunity a few weeks ago to test how all of this stuff worked together with a training session where we actually had people on site in 3 dimensions working with folks. I was supposed to be there and I got COVID, so once again, it reared its ugly head. The stakeholders that we've managed to work with over the year, I just put them all on a list because it was easier. Different training sessions, different people were able to show up. Trying to do this stuff remotely, had its challenges, but it provided a lot of opportunity for the folks in the region to work with the data at their own pace. Being able to do these training sessions in the overnight period. I live in Huntsville, Alabama. So for me, it was 10 o'clock in the evening to 6 o'clock in the morning, for many of these training sessions and such. But for them, it was 6 o'clock in the morning to 11 in some cases. And so some of these folks were taking care of their kids while they were trying to learn how to use SAR data, for their different jobs. And so hats off to all of them for the efforts that they put forth and all of the stuff that they shared with us. So what did we learn? They absolutely enjoy the ability to have real-time data at their fingertips faster than they would normally have observations. But they were very much not shy in showing us, what they wanted to be able to do with the data and where it worked and where it didn't work. Missing the peak flooding because we didn't have a satellite overpass. A reoccurring theme, how we define permanent water. Some of the processing is based on where we defined permanent water at. And in Bangladesh, the water folks, they were like, yeah, that's we don't care about that water. You defined it wrong. And then in Bhutan, they were like, no, we need that water. You're not giving us enough permanent water. And so it was a very interesting intersection of how the users wanted to be able to work with the data. And we had a broad spectrum of abilities as well. As some of these videos have gone through, you've seen we had some people doing some high level analysis and comparisons. And then we had some NGOs just doing simple comparisons to figure out where they needed to send supplies. And so it was a broad spectrum. It was gratifying to see that the information was easily usable and functionable with this group. But on the same token, they were very capable of giving plenty of feedback and pushing the science team to think about how to deliver data in a different way, but also to push the science and actually giving them the answers that they need, not what we thought they needed. And so, stepping back from that a little bit, going back to the idea of the themes across the SERVIR network, these hubs have been in existence for a while. And, as a scientist, there might be temptation of thinking, oh, I'm going to teach people, I'm going to create something, I'm going to do this. And really pushing back on the idea that code development actually did more to push the science in this project and the development of these ideas than any number of science papers that would have been put together, because the information actually needs to create a decision, not necessarily just a case study. And these hubs are very well versed in what the needs are of their areas. And so I won't belabor the information that's on this slide since Jim just talked about it, except to highlight that the work that Jim did in the HKH region was shared across the hubs in the networks that they already created. So the sharing of the information and moving it to Africa happened organically by the hubs actually sharing information through these disaster and water thematic conversations that are hosted by the SERVIR office, and to get these people talking for these ideas to be shared. Yeah, and that's led to the development, not just in the water and disasters. There's a whole plethora of examples that SERVIR has from this idea of, how you solve a problem in one place. It may not be the same problem at another hub, but yet the solution seems to be adaptable. And that's also, a learning experience for all the scientists that work in the SERVIR network, because, to make sure you design your techniques and your skills, not as a case study to go into a paper, but as a general methodology that can be utilized in lots of places and then localized to actually help them make their decisions. Another example is, we've already seen it yesterday, risk is defined by hazard, exposure, and the vulnerability of the area. And in the Mekong region, using the remote sensing data and a tool that was developed both in the Mekong and then with different folks across the severe network, they call it hydrofloods. And it's a Google Earth Engine tool that's got a lot of simple thresholding techniques to define where water is. And it was built a little bit as a stopgap measure, and it's just kind of grown organically across the different regions, to be able to figure out where each of these users need to be able to get their water expense from. As the capability increases, as the availability of the different satellite data, this gives them a quick tool, especially in the Mekong region, to be able to plot this. The World Food Program has this tool called PRISM. I'd only heard about it with working with Eric for this presentation, but it is a bit of a black box to the remote sensing scientists, but it does include a bunch of information from the World Food Program's perspective of different pieces and parts of information about the regions that they're trying to support. And so by having the hydrofloods or any type of water expense or remote sensing information flowing into that, combining with the socioeconomic information that the World Food Program has in these areas, this was a demonstration to show that by bringing that information together to move towards the idea of impact-based, actions in an area, either based on a forecast or based on an observation, or hopefully both. And so this was an example that was developed across a couple of the hubs to kind of assess whether or not this could be done and how if it could be done accurately. So next steps. Obviously, the AST projects will continue to work together. One, because SERVIR said so, but most of the PIs across these regions have also started to realize that the sheer amount of information sharing across these hubs, we may have worked in the HKH region, but as part of these themed areas of discussion, ideas are percolating. And, Jim already mentioned it, the idea of looking at how you can use a model and then simulate what the SAR data might look like based on the model information, and that idea is going to turn into something, because there's no way it can't now that we've had that discussion. And so work is already started on that to see if it's possible. The idea of the information and landslides in one section helping out another, and how do they may not have been able to fund all of the ASTs in those different areas, but that information is still going to be shared and still going to be used. The combination of the seemingly different projects, there's not enough time in this particular talk to show some of the examples of projects that have been combined and led to some really interesting results. And again, pushing the science to actually, support the decisions that need to be made rather than the case study that we're going to put into a paper. And then, I think the end goal has already been talked about in many of the presentations here, is the moving towards the anticipatory action, the moving towards, can we improve our forecast? Can we improve our observations at a point where we can make those decisions to help people before they're impacted, as opposed to waiting for the impact to happen and everybody being waking out. And then also, even in the long term, making those decisions towards building better, resilient areas, convincing people that living right on the floodplain, even in the United States, where we should know better, is not a really smart idea, but, having that information to share and getting people to understand it. And then, despite the fact that we have global models, I think it's been illustrated in numerous talks here, I don't have to belabor the points, but that regional and local tailoring of any model, any attempt at a tool is always going to be a requirement, and will certainly job security for the rest of us. And with that, I'll end my presentation. Thank you.
Thanks so much, Lori. Questions? Yeah.
Thanks, Lori.
You have to let it warm up for a second. Just wait, it'll happen.
It'll turn green.
It turns red, then it goes.
I'm waiting for.
Talk really loud, I'll repeat your question.
Sorry, picked it up.
I'll just, yes, here we go. Do you cut, or because there's so many, limitation of the, accuracy and so much noise in the remote sensing analysis and the modeling, do you have, or did you came across issues where people just kind of wave it off and say, this thing is not really helping us, or it's not accurate enough, and kind of that aspect of it?
Not as much as I expected. The feedback for the terrain in Bhutan and in Nepal made it hard to see some of the rivers that they had a lot of interest in. The side-looking aspects of the instrument, it certainly presented its challenges, but instead of being frustrated by it, we spent a lot of time talking about different ways we could process the data or different ways we could get at the answer. And so that led to a little side effort going on of reprocessing how we're actually approaching the algorithm to see if we can actually tease out a little bit more information. And then we spent a lot of time actually learning how each one of the different government entities did their measurements, and then tried to find some alternative methods to use the information together. I walked away I started this project not necessarily understanding a lot about hydrology, but I've spent a lot of time having to kind of bone up on it and stuff to understand how they're making their decisions currently and where it would fit. And then also to point out where the limitations are, and then developing the tools together. So not as much frustration as I expected. There may be something to be said for the fact that they don't have a lot of this type of observation, so anything's better than nothing, but I don't think that it's a place where we'd actually rest on our laurels there. I think it was more about how we can actually get at more information and where, and some of the efforts to bring the modeling and the observations together for that understanding to be better, to help with some of that gap filling.
Okay, I can get around in this.
Well, just want to pick your experience, pick your mind based on your experience working with users, stakeholders, and local people. Could you elaborate a little bit more about the importance of, you mentioned at the end of your presentation, the forecast flood mapping? How much requests do you receive about forecast flood map, and how do you fulfill those requests based on existing data and global system, like Dr. Nelson presented, flows, and you have but the flood map, forecast flood map, and the resolution? How do you deal with that and compare versus near real time that you have some satellite data? What about the forecast flood map?
Stakeholders in general, in the HKH region, the work that's been done was pretty well understood by the different groups there, and so strangely enough, I actually learned a lot more from them on how they use their forecasting models that were put into place. One of which was worked through with SERVIR, and then others that they have in the region already. In general, in the HKH region right now, my impression is that they were working through all the pieces separately, and then in the coming years, we're going to spend a lot more time how to use it together. Other stakeholders, I work with a lot of emergency managers and folks that are a little bit more on the impact side. And so to them, models are that hand wavy thing that somebody makes a map, they don't really know what goes into it, which I find a little bit disturbing, but it's also was my experience previously, so it's not that foreign. Interestingly, I've worked with some of the maps that have come from Ken Sparrow's group at Army Corps of Engineers, and there's a lot more tolerance in the communities that we've been working to support to understand at least the basics of where model information comes from, and how to use it more effectively. And so that's prompted a lot of us who work with remote sensing to improve our knowledge so we can actually show how it works together. And if we're looking at a model that's, worst case scenario, and then we show them an observation that's not that, at least be able to do the basics of explaining why, and then giving that feedback to the modelers of maybe we don't always have to show the worst case scenario, or at least we should mark it as such, again, trying to trying to be that go-between between all the different communities, but it's, I would say it's still a work in progress, at least for the stakeholders that I've worked with.
Last question, to get in this time.
Thank you, guys. Yeah, so I mean, one of the most interesting things that's in your presentation in Jim's one is really going from the global scale to the local scale, and one of the most interesting innovation, which scares me from a certain point of view. What you said, I mean, it's one of the challenges is really, trying to bias correct and particularize. Can you elaborate a little bit more on that? What is needed? I mean, really, to make a global model usable at community level, for example. What does it entail?
So I'll answer this question because I'm not a modeler, have never been, and when I had the one opportunity to follow that path, I was like, oh, please no. I love working in the observational space. That being said, the power that models give us to kind of show us what is coming, what is possible, or what we should be afraid of, can't be denied. I would say in most products, it would be the developing of the confidence in what it is you're looking at. The users that are modelers obviously want to have all of those technical, pieces and parts to understand how it's done. But if they don't have confidence in what they're looking at, whether they're a modeler or they're more an observation person or they're emergency manager, if they don't actually know what they're looking at, they're not going to build that confidence. And so I would say communication is probably hands down, but communication at the level that they need to be understood. So if you're talking to somebody who's a hydraulics or hydrology person, then talk to them at that level. But for a GIS remote sensing application person who's just bringing it in and wants to make sure they're showing it right, again, I think being able to speak at all of those different levels, and in my experience, not being afraid to say, I don't know the answer, but let me find you the right person, to work on building that confidence. Because again, if people aren't going to use tools people are less likely to use black box tools unless they have some sort of confidence that it's always going to work. And how you build that confidence, I think, varies on the region that you're in or the people that you're working with, but I'd say it's a lot of patience. And it's a lot of homework, at least on my part, to be able to answer questions, or at least to find the right person to answer the question. But understanding how workflows work together and not being afraid to say that this isn't going to work for your application, I think goes a long way towards that. But also understanding what they're actually trying to get at instead of telling them what they're trying to get at, would be the other part of it. Again, I think the co-development aspect, I think, allows people to step back and actually have a conversation instead of getting spoken to or at. So